This is page 44 in our notes. My colors are blue and green. This is actually going to take up 2 pages, so it's going to be 44 and 45 in our notes. This is standard EE3. This standard, there's lots of things or lots of parts to this standard. First off, we're going to learn how to combine and simplify. They call them algebraic expressions. Expressions are different than equations. Equations you can solve. Expressions you don't really solve them. So the first thing we're going to learn in this particular lesson is to simplify. And so I'm going to give you an example that you're going to see, and they're going to ask you to simplify. So first off, they're going to give you y plus y, and they're going to ask you to simplify that. So what does that mean, to simplify? Basically, you're combining that there's 2 y's right here, so y plus y is the same thing as saying 2 y's. Why is it not y squared? Y raised to the second power would mean y times y, so this is 2y. A term that we are learning here is called coefficient. Coefficient. The coefficient is basically the number that goes in front of the variable. So in this example, our coefficient would be 2. So the coefficient is the number that goes before the variable. You will always see a number in front of a variable. You will never see a variable and then a number next to each other. That's just not proper. So in this example, 2 was the coefficient. It really just means 2 times the value of y. You may know the value, you may know what y stands for, you may not know what y stands for. You just have to combine them together and say that's simplest form. This is expanded out, you simplify it together for that. Put a little line here in our notes. Move this up a little bit. The next thing we're going to do, you're going to see the directions that say solve and then state the coefficient. So state what is your coefficient. So solve is another word for simplify, and then state the coefficient. Those are your directions. So the first example I'm going to give you is x plus x plus x plus x. Let's see, 1, 2, 3, 4 plus x. Okay, so I want you to solve and then state the coefficient. So how can you simplify or combine those together? There are 5 x's being added, so that's the same thing as saying 5x when you solve it, and then your coefficient would be 5. It's the number in front of the variable. The next example, solve and state the coefficient to this, and you have y plus 6. Okay, so what can we combine together here? You see how there's 2 y's and then you have this number? These are what I'm going to refer to as apples and oranges. Your y's or your apples are the same, they both have a y, and then this is just a number. It's not 6y, it is just 6. So you can combine the y's together. Y plus y is the same thing as saying 2y, but then you see how you just have this plus 6. There's not a y or anything with it. You just have to write plus 6, and that's it. That's all you do for solving. You don't know what y is. You don't need to know what y is. You just combine it together for 2y plus 6. Your apples are your y's, and then just your number would be like your oranges. So what is our coefficient? Remember, coefficient is the one that has a number in front of the variable, 2. Our coefficient is 2. So here's our answer, 2y plus 6, and your coefficient is 2. Let's try another example to get an idea of what to do with apples and oranges. We're going to do m plus 5 plus m plus 4. And I want you to look at this problem. This problem has apples and oranges. There are m's, and then there are also just numbers. So if we just combine the m's together, we have 1 m here plus another m plus another m. I like you to circle the sign with whatever comes behind it because it tells you what to do with this m. This plus tells you to add. This plus tells you to add. So when I combine these three m's together, that gives me 3m. And then with those would be my apples. Then my oranges would be the +5 and a +4. They are just numbers. So when I add a +5 and a +4, that gives me 9. So I have a +9. So we solved the apples in green and the oranges were in blue. These have an m with them. This is just a number. You cannot combine this together for 12m. Your coefficient would be 3. Your coefficient 3 is the number in front of the variable. The next example that I have for you is n plus 3n plus n plus n plus 12 minus 8. So I'll give you a chance to write that and look at that. Again, I'm going to remind you this has apples and this problem has oranges. In other words, your apples would be like all of your n's and then your oranges would just be your numbers. So how can I think about apples and oranges to combine like terms here? Well, if I combine the n and then the sign with the thing behind it tells me what to do, add that 3 in, add this in, add this in. How many n's is that? This is 1, 2, 3 plus another 3, so that is worth 6 n when you combine all these together. And then your oranges would be your +12 minus 8. So your 12 minus 8 kind of tells you that gives us 4. And then this plus just kind of comes down right here. So 6n plus 4 is your answer. You cannot combine this together and say 10n because this 4 doesn't have an n. It's just a number. What is our coefficient? It is 6. Another thing you're going to see in your notes today, because you're going to see it in your homework, you're going to have directions that tell you to like terms can be added or subtracted. What do I mean by like terms? Kind of like our apples and oranges. They could be added or subtracted. So for these examples that I have here, I will give you 3x plus x. So what would that be if you add those like terms together? And some people they get this, there's 3 x's. When there's not a number in front here, you don't really put a 1 in front of the x. It means 1x, but you don't put a 1 in front of it. The 1's kind of implied because 1 in front of the x, like 1 times x is still just x. So we don't really put a 1 in front. But we read this 3x plus 1x, that would equal 4x. And that's what they're wanting you to do. So you get 4x. Another example, right below that, is 5w minus 3w. Okay, so these both have w's. So if you have 5w and you subtract 3w, then you'd be left with 2w. Let me do another example. If I have y and I take y away, what would I be left with? It's like 1y minus 1y. I'm left with nothing or 0. You don't put 0y, you would just put 0. Okay, I'm going to go over here, use these lines for some more examples. If I have 3p and I want you to subtract 3p, what am I left with? Again, that would be 0. You don't put 0p. If I give you this example, 4z plus 2z, is that the same as 6z? 4z and I add 2z, that would give me 6z. So yes, they are the same. You're going to have another part of your assignment. The directions are going to ask you to state whether each pair of expressions are equivalent. Like do they equal the same thing? Like does what I wrote what I wrote in blue, is it the same thing as what's in green? Is the right side of the equation the same as your left side of the equation? So you're going to kind of compare. If they're equivalent, you say yes. If they're not equivalent, you would say no. So the directions are going to say state whether each pair of expressions are equivalent. That's what your directions are going to say. And I want to make sure you understand that. In other words, equivalent means equal to. Like, is what's on the left of the expression the same as what's on the right? Are they equal? Equivalent means equal. So that's what you're thinking about, equivalent, equal. So the first example I want to write here, I'm going to write it and give you a chance to look at it, is f minus 6 and 6 minus f. Are they equivalent? Yes or no? You can circle it. Yes or no. Are they equivalent? Is f minus 6 and 6 minus f the same thing? No, they are not. Because if I put a 10 here for f, just for example, if I put a 10 instead of f, is 10 minus 6 the same thing as 6 minus 10? No, they are not equivalent. You can't flip those around with subtraction. Can't flip with, I'm going to call it subtraction. But if that was addition, 10 plus 6 and 6 plus 10, they're the same thing. F plus 6 or 6 plus f. You can switch them with addition. You can't flip those around with subtraction. Where did I get the 10? I just made up a number to plug in for f just to see. You know, is 0 minus 6 the same thing as 6 minus 0? Well, 0 minus 6 is negative 6, and 6 minus 0 is actually a positive 6. So again, that shows you that they're not the same. What if I give you this expression? Is b plus 5 and 5 plus b the same thing? Yes or no? So you could pretend to put a number in here for b to check it. Like, what if you pick 2? Is 2 plus 5 the same thing as 5 plus 2? Yes, they are equivalent. My last example that I'm going to give you on this page, 5c minus 5c, and is that equivalent to a minus a? Yes or no? I'll give you a moment to kind of think about that one. If you have 5c and you take away 5c, you would be left with nothing. If you have a and you take away a, you would be left with nothing again. So they actually are equivalent, even though this had the letter C's over here and this had the letter A. Could you put numbers in there just to check? Yeah. Like, what if you put the number 1 right here? 5 next to a 1 means multiply. 5 times 1 is 5, minus 5 times 1 again, which is 5. 5 minus 5 would be 0. What if you put the number 2 in here for A? 2 minus 2 would be 0. So they are equivalent. And we're going to go into the next page of our notes, which is page 45.